Welcome to the video on Module 4. In Module 4, we will discuss about different types of simulation softwares. Simulation softwares are of two types: circuit simulation software and equation solving softwares. Different circuit simulating softwares are SPICE simulation software, an example for equation solver software are MATLAB, Scilab, and Octave. In this video, we will discuss about a brief introduction about SPICE software. Let us start our exploration in the field of circuit simulation. Example for circuit simulation software is SPICE software. In the SPICE software, there are different varieties of SPICE softwares are there. In this, we will discuss about P-SPICE software. In development of circuits in olden days involves designer. There may be a circuit idea in the designer mind. The designer will design and draw the circuit by hand. Then he or she will implement it on a breadboard. After rectifying all the practical issues, it will implement on the PCB. Then they will introduce the finished product. That is, there is a circuit idea in the mind of designer. Then the designer will draw the circuit by hand. Then he or she will implement it on a breadboard. After clearing all the issues or practical issues in using the breadboard, he or she will introduce it in a PCB and he will develop it as a product. But nowadays we are using computers for developing and designing software. For that we are using computer software or simulation software. So there may be a circuit idea on the mind of designer. Then the designer will design and implement the circuit using a simulation software. Then directly he or she will download the designed simulated circuit on a PCB. Then that PCB will implement the circuit will implement on PCB and they will introduce the finished product to public. That is, the simulation software will reduce the burden on the designer. That is, there is a circuit idea mind of designer, then he or she will implement it using a simulation software and he or she will rectify all the practical problems and any issues related to that circuit, and he or she will directly download it on a PCB and he or she will produce this as a product. When sequence of design and simulation describe the circuit to the software, you should have to describe the circuit to the software. Then simulate the circuit using that software. Then we will get the output or response of the circuit. Then that circuit will download it to a PCB. Then the designer will develop the final product. This is the sequence of design and simulation. Now we are going to discuss about SPICE model. The full form of SPICE model is simulation program with the integrated circuit emphasis. There are different types of SPICE models are there: HSPICE, RANSPICE, IGSPICE, PRICE, PRECISE, PSPICE, AccuSym, Cadence, SPICE, SPICE Plus. These are the different types of SPICE models. In this we will discuss about PSPICE, which is introduced by Microsym Corporation. Up to 1984, SPICE was available only on mainframe computers. In 1984, Microsym Corporation introduced the version of SPICE compatible to personal computers. This gave the birth of PSPICE. PSPICE means PC version of SPICE software. There is a PSPICE editor file is there. That file is file extension is .cir. Then this .car file is go to SPICE engine. Then it will produce the data file .dat. Then that data will give us a output into probe file. Another PSpice model is PSpice schematic. You can draw the circuit using the PSpice simulation software. That file is saved extension .sch. Then this simulation software will directly produce the netlist, and this PSpice schematic is directly given to SPICE engine. Then the SPICE engine will produce the data file, and which is given to probe file, which is the output file. Another version of PSpice is the ORCAD capture. The file extension is .opg. It is directly given to PSpice engine. Then it will save in the output file as file with the extension .out. This is the workflow of the SPICE model. Either we can write our circuit, explain our circuit in a .circuit file, or we can schematically draw our circuit in a PSpice workspace, or there is another schematic version of SPICE is known as ORCAD capture. ORCAD capture also we can directly draw our circuit, but it is saved with the file extension .opg. This ORCAD capture is more precise than that of PSpice schematic. In ORCAD capture, we can model a component with a different voltage and current parameter, temperature parameter. We can give the current specification, voltage specification, temperature specification, and we can develop a component using ORCAD capture, and we can use that developed component in our circuit. That is the advantage of ORCAD capture. First one is circuit file. In both SPICE and PSpice, a circuit is described by statements that are stored in a file called the circuit file. The file extension is .cir. This is also known as netlist file. Format of circuit file is there should be a title, then circuit description, then analysis description, what type of analysis we are going to do with the circuit, with that particular circuit. That is the analysis description. Then output description, what type of output we need, voltage output or current output, like that, what type of output we need from that particular circuit we can describe using the output description. At the end of the statement will end using the statement .end. Use uppercase for coding. Coding is not case sensitive. For example, consider the given example of the the circuit consists of a 9 voltage DC input, 2 resistor R1, R2 and 1 capacitor C1. First we will write down the nodes. Now we are going to write down the SPICE equation, SPICE program. The SPICE program consists of the title of the program. The title of the program is we are going to analyze a we are going to perform a DC analysis of a simple RC circuit. And next is the circuit description. Circuit description means first is the DC voltage VDC. DC input voltage is denoted by VDC. Name of the component. First is the name of the component, then we will give a space. Then that component is between node 1, name of the first node and name of the second node, and the value of the parameter. First parameter we denote it as VDC, that is the voltage that is placed in between node 1 and node 0, and the value of that voltage source is 9 volt. Then there is a resistance R1. We will name it as R1. You can give any name. First column denotes the name of the component. Second is the first node. Third is the second node. Fourth column denotes the value of that particular parameter. Next, there is a resistance R1 between node 1 and node 2, and the value of that resistance is 3 kilo ohm, 3K. Then second resistance R2, which is placed between node 2 and node 0, and its value is 6K. When we denote the DC voltage source, we should have to denote the polarity also. First node name denotes the positive polarity. Second node denotes the negative polarity. That is, node 1 is connected to positive terminal of the battery and node 0 is connected to negative terminal. So, we will give positive terminal, node terminal name as second row. That is why VDC is in between first node and 0th node. According to the polarity, we will give the node name. Okay. Then there is a capacitor C1, which is in between second node and 0th node, and its value is 5 microfarad. 5 microfarad. Micro is denoted by the letter U. Then end of the circuit dot end. Then this program will, if we run this program, the program will do the DC analysis, and the output window will look like this. The node name, first is the node name of the node, first node, then voltage at node 1, that is for the node 1 the voltage is 9 volt, the node 2 the voltage is 6 volt. Then name of the voltage source V1, this V1 will act as a source and the source current will -1 raised to -3 ampere. -1 microampere is the source current or current due to voltage source V1. The total power dissipation is 9 e raised to -3 watts. This is the output window. After running the program, we will get this output window. Then different symbols which we can use in SPICE model are for voltage. For voltage unit, we can use VOLT, volt per ampere, AMP, hertz, HERTZ, ohm, OHM, H Henry, F farad, DEG, degree. Some special characters which we can use in our program are plus. Plus means continuation of a line, star, starting of a command line, then semicolon, comment, within a statement. Within a statement, we can comment our program using a semicolon. The vectors which we can use as element values are F for femto, P, capital P for pico, capital N for nano, U for micro, M for milli, capital M for milli, capital K for kilo, MEG, capital MEG for omega, capital G for giga, capital T for tera. In SPICE, either we can describe our circuit using program like this, or we can give it as a schematic. That means we can directly draw our circuit in a workspace. Then that file will save as a SPICE schematic file, and the extension of that file is .sch.